Let's talk about what is SocGholish, right? SocGholish is a JavaScript-based framework that's been active since like 2017, and those threat actors, they compromise millions of websites, right? To, when you visit the compromised website, they'll deliver the landing page, which is a fake update page that I'll show the demo on the next slide. So they're using that to distribute their JavaScript payloads, right? And do not mistake simple for stupid here, because these threat actors, they're very picky. So they're using traffic distribution systems, in this case is Kitaro TDS, for victim profiling. So they're making sure that us researchers coming from a sandbox, we won't be able to see their malicious page, right? So using that for victim filtering. I would like to think that it operates as a malware as a service. I also like to think that it's initial access brokers. So it's been previously linked to Evil Corp, and some of you who have been in threat intelligence field might have heard about Evil Corp ransomware threat actor group. So they're leveraging a fake update to deliver wasted locker ransomware. And it was, I think, back in 2020. And now, within the past years, 2024, 2025, it's been Ransomware. But some of you might have heard the rumors that Ransomware pulled a little exit scam because allegedly another threat actor, ransomware group, Dragon Force, they hacked the Ransom Hub infrastructure, so they are no longer in the scene anymore. But what I've read in articles that from Fortinet, I believe, another threat actor, Kantuk, which I believe works closely with SocGholish, and I'll explain why later. They are deploying interlock of ransomware now, so it will be interesting to see where SocGholish is going to handle their keys, right, to which ransomware threat actors later on. Why it works? Because again, social engineering, it's very, very effective, right? There's no 0 days, no vulnerabilities. You just trick a victim because, us people, we're always taught to update our browsers, right? To update our systems, reboot the computers, make sure everything is running and updated. There's no 0 days, no vulnerabilities needed. And the buyers always change, like I said, right? The threat actors are always going to be different ransomware threat actors, and SocGholish still going to stay at the same place, selling the access to initial access brokers to other people who are willing to buy the data that steal off the machines. And this is the little demo. What happens in a few seconds when the visitor, visits the compromised website? Right, it's just browsing around. They get the fake update page. When you click on Update Chrome, it will trigger the download of the Google Launcher.js file. It's very active, right? It's effective because people are double clicking. And this slide, it's a little bit fancy. I know, I was trying to build a chart by looking at over 1,000 of cases, and sorry, they still make the weird sound. To map out every industry, it was such a pain because I would have to Google every organizations and try to figure out what industries they belong to. And as you can see at the top, we see a lot of IT and technology industry. I mean, it makes sense, right? Because managed service providers, they provide services for other businesses and organizations. Manufacturing takes the second place. I mean, people focus on production, right? They don't care about security much. No offense to manufacturing people here. Constructions, financial services, real estate, staffing, HR. Every industry is represented here, which means it's just a numbers game, right? Again, they compromise millions of websites, and they're just waiting for the right people, the right audience to double click. Cool. This slide looks terrifying, but this is actually what happens within the blink of an eye. So when you saw the demo video, how you got that landing fake update page, this is what happens, right? You visit the compromised website and you see the injected script called index.b3.js. That script reference another script, script.js, right, at contentwebsiteanalytics.com. And that script.js reference another script, which is roadmap life insurance masters.net. That's the gating engine. So if you wonder what the gating engine is, remember the Kitaro traffic distribution system that they're using for victim profiling? After you pass that check, you actually land on another layer. This is going to be the anti-evasion layer. So they're going to check if you are the returning visitor on the website, right, through the local storage API. They're going to check if you're opening your DevTools in your browser by checking your dimensions, right? Because if you ever open your DevTools, you see that you have the split window and your dimensions kind of changes in the browser. they're checking if you're the WordPress administrator by looking to WordPress logged in parameter within document.cookie. So they're making sure that WordPress administrator, they never find out that their website is compromised with SocGholish. And guess what? You need at least 10 mouse movements before they'll give you a payload. So they're making sure you're not the scanning engine. They're making sure you're human, right? Who performs all those clicking and mouse movement actions. So after passing everything, right, they finally only after that they'll give you the fake update page, right? And you see those little like pixels here. So those are tracking pixels. If you know like Facebook and Google, they monitor the advertising campaigns through the tracking pixels, right? So we request a little tiny image from the server logs the request on their side, and that's how the attacker are able to track whenever you click on things, whenever you hover your mouse. So it's like they're running their conversion analytics on their own malware campaign, right? How sneaky is that? Cool. So you might be wondering, okay, SocGholish, like they care about giving the keys to the threat actor, ransomware threat actors. What about John Doe who's sitting in his basement using his own computer, right? Bring your own device. Do they even care if like John Doe is not domain joined? They do, right? Because like I said, they care about stealing your data, not just giving your data to ransomware threat actors. So in this case, if you are domain joined, they're going to drop this backdoor, which I call the bread and butter of SocGholish because they love using this backdoor. It's a Python reverse SOX proxy backdoor, and it has 6 layers of obfuscation with anti-analysis, right? Anti-VM. So they're making sure you're not coming from VirtualBox, from VMware. They're checking is debugger present flag is present. So if all of those checks are present, right, they're not going to run the payload itself. They're also going to drop the reverse SSH channels. So in this case, from the intrusion cases I've seen, not related to SocGholish, but for other threat actors, the reverse SSH channels are usually not running a scheduled task, but SocGholish, they deploy, ouch, my ears, they deploy that as scheduled task, right? So make sure, if you ever do threat hunting, look for reverse SSH channels running as a scheduled task. Living off the LAN binary. So they have used SortUtil, which is a legitimate Windows tool to manage the certificates. They encode a SAM database, which contains credentials, password hashes, right? So they can use that later to perform the pass a hash attack or crack the credentials offline. So Active Directory enumeration and browser credential harvesting. So, they're going to map out what you have installed in your environment, right? I mean, what's running your environment, domain controllers, file servers. They're going to map out the whole environment so they know where to move laterally next. And then they're going to still care about your browser credentials, right? So we'll talk about that one later. And finally, they do the handoff to the ransomware threat actors, the cool guys. Okay, you're not domain joined. What they're going to do, they're going to drop the GhostWeaver backdoors, one of my favorite backdoors. And it's actually deep-poppy encrypted. So by being deep-poppy encrypted, it's using the local scope machine, right? So if we are reversers, defenders trying to decrypt that, we cannot decrypt that offline on another machine. We have to decrypt it on the infected machine, unless we grab the security and system files and run Mimikatz to get the master passwords to be able to decrypt that file. So it takes a lot of steps. They have multiple plugins from the GhostWeaver, so we'll talk about those plugins later. Our TRS backdoor is what we're tracking internally, and we haven't talked about it publicly, but it's being used by Kangtuk and SocGholish threat actors, and that's why I think that they're working together because they deploy the same backdoors, they run the same reconnaissance commands. So what RTRS does is that it has the dual C2 channels, right? The first one is the Tor. They're using Tor as a primary channel. So if you see consensus data and key stores under the temp folder, it means that your endpoint is probably running the Tor client. And the secondary channel is the domain generation algorithm. So they generate about 10 domains per execution. They're going to use several words from 52 hard-coded words into the RTRS backdoor. And this one, they're going to focus on the data theft, right? To pass it over to other threat actors other than the ransomware threat actors. And this is what we see at Huntress. So the first one you see, this one is the SSH tunneling, right? So they create a scheduled task for SSH tunneling. And the second one is they're running the Python proxy backdoor. So every time when we have new clients enrolled in our environment, we see multiple endpoints having that scheduled task running, and which tells me exactly like they like to move laterally very fast, and they like to deploy this on as many endpoints as possible because the threat actor can always tunnel back into the network and access everything. Cool. So what they're going to do if they're domain drone, this is from like over 1,000 of cases, and this is what we've been seeing consistently being used. The first one is a net NTLM stealing technique. So they are going to inject a malicious image tag into an Outlook signature. So whenever you send an email to your coworker, they're going to open the email, and that would trigger the Windows endpoint to try to fetch the signature file, the image file, like from the C2 server over WebDAV resource or SMB. So the attacker has the listener running, right, like responder on their end, and they're going to catch the NTLM handshake. By that, they're going to steal your NTLM credentials. Active Directory enumeration, they like running directory searcher and ADSI queries for servers, email addresses, right? Again, they're mapping out, your infrastructure. They're trying to figure out what company you're working for, right? And see if it's even worth passing it to ransomware threat actors. LNK propagation, it works similar to Outlook signatures, right? So instead of like injecting malicious image into the Outlook signature, they're going to like browse through your network share. They're going to drop the LNK file under every folder in your network share, right? So whenever you browse to your network share to access some documents, files, images, that will trigger. You don't have to even press on .lnk, right? All you need is just the user to browse through the folder, and the Windows endpoint is going to try to fetch that image, right? Because the path will have the URL of the C2 server. So they will try to perform an SMB authentication to the C2 server. And we've seen a lot of cases where, the client would get back to us and ask us, we see a lot of run DLL32.exe talking to like microhosting.pro domain. Like we cannot pinpoint the initial access or what's going on here. This means that probably there is a LNK file that SocGholish dropped in one of your users' shared folder, and they just browse into that, which triggers the run DLL32.exe command. And again, they can steal your NTLM credentials. RDP mining, so they don't even have to touch your Active Directory to be able to know where your other endpoints are located, right? They're going to pull the registry key, terminal server client. This is where it tells you where your endpoint has been connected to through the RDP. That's where they're going to go next. Browser credential theft, so they're going to just directly read your browser login data. They're going to output every result they're running, right? Net NTLM, AD enumeration, LNK propagation. Everything is going to be outputted to the RAT file. I don't know what RAT stands for. I probably should ask the threat actors after this. A RAT file followed by 5 hexadecimal character .temp. So those files are going to be under the temp folder. Make sure to look for the file creations events for the RAT files for the detection purposes. All right, so this is what we see. This is the enumeration command they're running, right, using the directory searcher or ADSI. They're querying the computer object, right, where the operating system would contains the name server, but they're trying to figure out where your servers are at. So I have to tell you that I barely ever see the legitimate commands being ran through the directory searcher or ADSI at all, which tells me that this is being automated by threat actors. The second command is the RAT command, right? They're outputting the signatures into the RAT file. So they're making sure that, your signatures are poisoned with their C2 server, right, that I was talking about earlier. So they're making sure that that data is present in the signature. They're going to exfiltrate that RAT file to their C2 server and then delete that from the host. Cool. I was talking about GhostWeaver, the plugins. They have 2 plugins, right? The first plugin is the man-in-the-middle browser. So what they're doing, they're going to install the fake root certificate called OV-VeriSign-CA. What it does, so the Windows endpoint will decrypt the HTTPS traffic, right? It can intercept the traffic because the Windows endpoint will trust that certificate in the Windows certificate store. It's config-driven. By config-driven, I mean what it does is it has 2 rule types. So the form grabber has the inject and the block. So the block rule types will block all the analytics platform like quantum metrics so they cannot tell if the user is interacting with the injected script, right, the malicious script. And for the inject, they're going to like have the patterns, the regex patterns. The regex patterns contains the pattern to look for the banking sites and crypto sites. So if you visit Bank of America, Chase.com, they will inject the malicious scripts into that, right? So they will redirect you to their website where they have all the landing pages ready. Every template is for like a specific banking sites, right? And then you won't be able to see that in the URL tab. You have to open the web dev tools to be able to to tell. And I'll show you later how it works. So JA3 evasion, we probably as defenders, use JA3 fingerprinting to track or attribute malware based on the TLS fingerprinting, right? Which uses like cipher suite orders. And so form grabber, it randomizes to the TLS cipher suite order at the Windows SC channel using like different APIs to shuffle the encryption order. Which means if you are tracking malware based on their JA3 fingerprinting and you already have a database of known signatures, the bad signatures, you won't be able to track form grabber because it will create a different signature every single time for JA3. Stealer plugin, they care again about your browser credentials, right? They're going to steal Chrome, Edge, Firefox, whatever you have running in your browsers. They're going to steal your Outlook credentials, right? Username and password from the registry keys. And you see Chrome Piper here. So this is the named server pipe. They use that for injecting the stealer through the process hollowing technique under notifications _helper.exe. And some of you who might have been following the research about stealers, right? Chrome kind of make it more difficult nowadays for threat actors to decrypt the cookies. So with Chrome version 135 and up, they are going to inject into the trusted Chrome process, elevated process. And that's how you get the decryption key to decrypt the cookies, right? If you're running Chrome versions, less under 135, it just falls back to deep copy decryption. Cool. So this is what it looks like when the website is being injected with a form grabber, right? You see the total legitimate website URL, right? But when you go into the web dev tools, when you check the sources, when you check the network, you see the injected script that is obfuscating. So for the user who is not technical enough, right, they won't be able to tell if they have the form grabber plugin running in their system. And how can we defend against that, right? It's pretty easy. If you like doing threat hunting, make sure you look for scheduled tasks running Python under program data folder. They always drop the Python SOC's reverse proxy backdoor under program data folder, under the randomly named subfolders. So make sure that's a good indicator. Look for SSH reverse tunneling being scheduled, right, to run every single minute or something, or every 6 minutes. Look for conhost headless PowerShell because 100% of the time, threat actor will run it, right? No legitimate user would create a scheduled task to run headless PowerShell because what it does, it will not create any visible windows when the PowerShell starts to run for the user. Look for the red.temp files under the temp folder, right? I mean, they like to delete those files. So as long as you can, monitor the file creations and file deletion events, you can easily hunt for SocGholish by the red temp file creations. Directory searcher, ADSI searcher queries, make detections for those queries because 99% of the time, I've never seen any administrator running this for legitimate purposes. So make sure to create detections around the ID enumerations, right? Because it always leaves fingerprints. Schedule task, look for Google_maintenance_worker because those threat actors, they don't change the schedule task. And when you see Google maintenance worker present on your endpoint, it means it has the form grabber running and you should tell your user to reset banking credentials, right? Figma update schedule task. This is the RTRS backdoor that we've been tracking. Make sure to look for Figma update task. And lastly, configure your environment, with a group policy to reassign the default handler for script files like JavaScript, DBS files, right? I know it takes time, but it helps to remove that, foothold of the user double click on JavaScript files, right? And it won't break anything. Like your browser will work fine. Your web developers are going to still execute those files perfectly fine. It's just, make it harder for the threat actors to execute in your environment. And yeah, if it ever breaks anything, you can always message me and yell at me for that, but I'm pretty sure it won't break anything. So the last advice is very effective. Make sure to deploy that. And with that, thank you so much for attending this talk. I really appreciate your time. I hope you have a wonderful day and enjoy the RSA.